Good afternoon, I'm Chiayan Tseng from the Taiwan Power Company. I feel very honored to be invited by the Energy Xcelerate to share our experience. And in today's speech, I will show you what is the 24 hours a day and 7 days a week and carbon-free electricity. And the 24/7 CFE demand from the AIDC and the advanced fabs. And the second part, I will show you how to model the various solutions and applying the PLEXOS to investigate all the solutions. And okay, here's what we will cover today. And about the Taiwan Power Company, Taiwan Power Company is the largest and the state-owned power utility in Taiwan, operating in the generation, transmission, and the distribution, and the sale of the electricity. And our capital is up to the $19 billion, and we recently reached roughly the 29,000 employees, and our customer is up to the 15 million. And so Taiwan is a small island near the East Asia, and the lack of all kinds of natural resource. In Taiwan, ICT and the AI manufacture is the quickly development, and need more renewable energy. And from these two pie charts, Taiwan Power Company has decreased the coal-fired energy and increased the capacity of the renewable and the gas fire. And in the end of 2025, total capacity of a Thai power system was approximately 60 gigawatt. And now we talk about what is the 24/7 carbon-free electricity. From the two perspectives, we discussed the difference between the RE100 and the 24/7 CFE. Firstly, regarding to the organizational definition, and the RE100 focuses on the renewable energy and the storage charged by the renewable. And the CFE includes the thermal power with the CCS and the nuclear energy, in addition to the RE100. According to the time match, RE100 focuses on the annually the matching between the demand and the supply. And the 24/7 the CFE emphasize the hourly matching demand and the supply. How to estimate the progress of the 24/7 CFE? So Google published the CFE score, measures the percentage of the hourly matching between the energy demand and the carbon-free supply across all the hours of the year. And why need the CF score? The motivation of the CF score is to track the gap and drive the green tag. And how to start the 24/7 carbon-free electricity? In 2017, Google has matched its global annual electricity use with the solar and the wind purchase, but they still rely on carbon-based power in some times and in some places. In October 2018, Google first published a paper showing the concept of the 24/7 CFE. In September 2020, Google announced the ambitious goal. By the 2030, they run its all the data center on the carbon-free electricity everywhere, every hour, and every day. So recently, the 24/7 carbon-free correlation and is established the major founding member includes the Google, AD, Vodafone, and others. So we talk about the trend of the AI data center. In the 2021, the Bitcoin mining stimulated a massive surge in the global electricity demand. And in the end of the 2022, the OpenAI released the ChatGPT and causing the demand of the AI training model to explode. And then now everywhere, everyone is trying to apply the AI model to influence all the fields. The NVIDIA CEO Jensen Huang has emphasized that power is the key component of the AI ecosystem. When the AI model from the training to the inference, so the energy usage pattern changes from a high density, the path, to the steady, the pattern. Okay, from as shown the left, according to the forecast from the IEA, the energy consumption of the global AI will be more than double the current level. And on the right side, we discussed the Taiwan, the situation of the AI development. And the two advantages of the AI development in Taiwan, one is the supply chain that streamlines the construction of the AI DC among the IC and the cooling system or server, the components and others. And the other is Taiwan is the center of the East Asia and the conjunction of the Asia and the Pacific. So over the low latency, the connection. And it talk about the key challenge of the TPC. You can see that in 2025, TSMC, the electricity, the consumption, actually surpassed the 25 terawatt hour, about 10% total, the total consumption of the Taiwan. With the AI chip, the tremendous growth. So TPC faced the pressure to supply the power to the TSMC, the advanced fabs. However, power grid congestion in Taiwan, such as the regional imbalance and the grid expansion, limited the expansion of the AIDC and the TSMC, the fabs in Taiwan. So to overcome mention the challenge, so Taipower tried to implement the two strategies. One is the power couples, similar to the co-location concept, integrate a new renewable energy source and the gas-fired power plant and the AIDC or fabs in the same areas. So this approach offers several advantages. Accelerating the power plant construction and reduce the congestion and ensure the overall grid stability and maintain the fair electricity price. The other strategy is the DC phase. In the 2025, April and the Taipower discussed the data center flexible low initiative. This enables the AI DC becomes a dispatchable load, where AI DC can reduce the working load to support the grid the frequency, the regulation, and the balanced energy, the demand, and the CFE supply. So before introducing the methodology, I would like to highlight the key takeaways. The first is the 80% the CFE score threshold. In order to reach the 80% the CFE score, combined solar and wind is the most optimal strategy. The second is the concept of the 24/7 CFE reliability. That is different. The CFE score, the definition is the fraction of the hours with the 100% CFE score. It helps us measure the reliability of the CFE, the supply. So the reliability scales nonlinear with the score as the battery storage serving as a reliability booster. So especially after the surpass the 18% threshold. In the last mile, the final mile to the 100% 24/7 the CFE, in addition to the power couples. Now, DC flex should be considered a potential alternative to the battery storage, but it depends on the case-by-case analysis. So, why to model in the 24/7 CFE solution? Recently, the many key AI-rated companies such as Meta, Microsoft, Google, and Amazon have chosen to invest the infrastructure in Taiwan. To date, TSMC has planned the construction plan and include fabs and advanced packaging in the factory. Some are currently on the construction, and others was in trial production. So with the growing demand of the AIDC and the fabs, we try to build up the models to explore the potential solutions. Okay, this slide is very important. Explain how to explore the various solution by PLEXOS combined with the three approaches. In the first approach, we will build up the AI learning model to produce the uncertainty the renewable generation data, collect the historical generation data of the renewable energy with the 5 years, and try to seasonalize all the historical data and apply this data to the training the AI model. So this approach captures the seasonal trends and the stochastic intermittency, allow the model to generate over the 1,000 annual hourly generation data of renewable energy. Next approach, using the PLEXOS to model the power couples and combine the AI generate the 1,000 data to run the Monte Carlo simulation. The process allows us to evaluate a wide range of outcomes of each solution. Finally, we apply the greedy heuristic algorithm to maximize the CFE score by selecting the asset with the highest marginal effect in each round. Okay, this slide shows how we set up the key settings in this model. Talk about the result as shown in this slide. We have plotted a figure of the cost per megawatt hour against the CFE score. It contains circles of the four different colors. Each represent a different capacity of the battery storage. And for example, green circle represent all the solutions with the 1 gigawatt capacity of battery storage. And there is a yellow, the circle, okay, serve as the baseline solution, representing the annual matching of the RE100, which the CFE score is about 68%. So the plot is show us one important thing. In order to surpass the CFE score threshold of the 80%, 90%, and the 98%, the battery storage is the faster way. However, each additional unit of the battery storage, so as an incremental the cost of the $44 per megawatt hour. Okay, we can see the 3D visualization, the plot. The three axes represent the capacity of the PV, offshore wind, and the battery storage, and each sphere is the unique solution. And the diameter of the sphere represents the cost. The largest the sphere, the higher cost. And the color of the sphere represents the CFE score. The greener the sphere, the higher CFE score. Okay, the red design path to the 100% CFE score is nonlinear, and up to the 80%, the mark, the priority is maximize the CFE per dollar by scaling up the PV and the offshore wind, and to build up a low-cost foundation. And beyond the 80%, so the structure shifts to bridge the final gap, and we enter a phase of the exponential capex growth driven by the battery storage. As shown by the red, the decision path, so storage become an important driver for the reaching the 100% goal. So to optimize the total cost, we recommend a phased approach. Scale the renewable capacity now and integrate the battery storage as the technology cost decline over time. So for now, we try to introduce the more sensitive criteria. We define the CFE, the reliability, as the fraction of the hours, and with the 100% CFE score. From this example, so we can see CFE score reflects the total clean energy value. It acknowledges the partial success by averaging the matching percentage across the all time. And in contrast, CFE reliability measured how often will 100% CFE. So according to this example, so the CFE reliability and represent the annually the probability of the 24/7 CFE. It will help us aggressive achieve the goal 24/7 CFE. In the conclusion, in the early stage, our priority is maximize the return on investment by combine with the PV and the offshore wind. However, to achieve the last mile to the 100%, battery storage become an important necessity. And unlike the CFE score, CFE, the reliability is a zero tolerance, the challenge. It offers no partial credit. So every single hour must be perfectly matching. And the CFE, the reliability, scales nonlinearly with the CFE score. And once we cross the 80% threshold, the battery storage acts a powerful reliability boost. So to reach the 100% CFE without over investing in batteries, we introducing the DC Flex. By utilizing the operational, the flexible workload shifting, we possibly bridge the final gap more efficiently. And our next step is to quantify this the operational cost and integrate DC Flex into our the PLEXOS model. And last Friday, so Google announced that it has signed a 1 gigawatt data center demand response with the utility, the partner in the US. So this last news strengthens our faith to investigate how the DC Flex help AIDC support the grid stability and achieve the 24/7 the CFE. And we have 3 learnings from this project. And one is our first learning that customer now demand the real-time transparency. They are moving away from the traditional annual report and want to know where their power comes from by the source tracking. As customer, in a second, as customer become more knowledgeable, so power supplier need to utilize the precise wide ranging data to customize the power supply solution that meet their specific and professional needs. Finally, we believe the power industry must be full of patient, flexible, and the agility, both internal and external, to overcome any challenges we face in the future. Thank you very much. Any question?
Okay. Thank you, Chiayan. Any question from the floor?
I was going to ask about the tracking that you do. Like with the CFE, it's normally you're trying to track every hour and report on that. Is that something you do based on the units dispatched, or how do you sort of aggregate and sort of, for sourcing to say this energy came from this source?
You say the CFE source from?
The energy tracking to say, my energy came from this solar PV or this wind farm. How do you sort of aggregate and do that? Because I know it's quite an intensive exercise to track that.
The source tracking is the big problem. And so we try to get all the renewable energy resource into the same area and the direct supply to our customer. So if the efficiency of the renewable, the gas-fired power plant can supply to him, so we can easily to measure and track the source comes from.
Perfect. Thank you.
Thank you.
I missed a little detail about the DC Flex program that you had on one of your slides, but I assume it to be a kind of demand side, like a DSM program, right? where the load is essentially being modulated. So has there been any, has there been any analysis around the willingness of the the data centers to participate in a program like that, to shift and modulate their load to different times of the day? I can repeat my question.
Okay.
I missed a little detail. Am I correct in understanding the DC Flex program?
Yeah.
That is like a DSM program. You are essentially asking load to change, like modulate to a different time of the day, right?
Yeah.
Okay. Has there been any analysis as to the willingness of the load to participate in a program like that, like shift their load to a different time?
Oh, so DC Flex.
DC Flex，它是 based on 它是 force 那个 load changing 嘛，那个 load 是 change，so 你有想过把那个 load 就说有uncertainty做一个 uncertainty。
Okay. DC Flex, we try to understand the cost of the demand response, and we try to implement the cost and of DC Flex, and the DC Flex and the other resource compete, and we can find the best way to use in the DC Flex.
Okay, thanks.
Hi. You've identified, obviously, that the cost of providing emissions-free electricity, once you get past about 80%, kind of goes exponential with the amount of storage that you need to build, and the amount of storage you need to build goes up and up and up with every percentage you go beyond that. Have you looked at using sort of biofuels, with like either a gas turbine or diesel generator, but running on biodiesel or biogas for that last sort of 5 to 10% where it gets really, really expensive to do it with storage? Because you still end up with a zero emissions solution, but it's probably a lower cost one.
You say do the sensitivity analysis by the gas price, the fraction.
Yeah, using either like biodiesel or biogas to run a backup generator to cover that 10% of the time when you don't have storage available.
Biodiesel, and no, we don't consider biodiesel. Yeah, because we want to achieve the 100% CFE. Biodiesel is not belong to the CFE. So just only the two way. One is add more the battery storage, and another is try to implement the DC Flex.